So we've got two new rules here. If I see an integral that involves some constant, I'm going to call that a squared minus x squared, I'm going to substitute x equals a times the sine of theta. And this gives me access to the formula a squared minus x squared, or a squared minus a squared sine squared of theta, is equal to a squared times the cosine squared of theta. Right? That was my first couple videos. What we just saw is that if I had instead a 1 plus x squared, I can substitute in x equals the tangent of theta. And this gives me access to the formula 1 plus tangent squared of theta equals secant squared of theta. Right? That was exactly what I did in my previous video. More generally, if this was some constant, I'll call it a squared plus x squared, then I'm going to use the formula x equals a times tangent of theta. And that will give me access to the formula a squared plus a squared tangent squared equals a squared times secant squared. All this in theta variables. So the last thing I've got to worry about is, well, I have subtraction going one way. What if I had subtraction going the other way? Right? I can't use my sines and cosines formula here. And I can't use my tangent formula here. Or can I? So I've been using the formula 1 plus tangent squared of theta equals secant squared of theta. But now I need something squared minus 1 is a trig function. So I'm going to subtract 1 from both sides of my formula and say that tangent squared of theta is equal to secant squared of theta minus 1. So here, I'm going to say that x equals secant of theta. Now let's see that in an actual problem. Let's integrate. Let's see, I want the square root of 1 minus 4x squared dx. This one's a little bit more tricky. I've got a coefficient